Hello, this is Professor Bolduc, and today I'm going to discuss the oxidation-reduction reactions. Another name for these reactions are the redox reactions. So let's start by giving you a definition. Okay, these redox reactions are actually a chemical reaction. So remember, chemicals are made up of atoms, and so these atoms consist of neutrons, electrons, and protons, and it's the electrons that play an important role. So electrons, they play an important role in these reactions. These electrons during chemical reactions can either be shared among atoms, they can be gained by one atom from another, whereas if one gains the electrons, that means that another atom has lost the electron. So lost. So these electrons can be shuffled or moved around. And it's the energy that holds these electrons. When these electrons move, they're going to move with energy. So this is going to be the basis of our metabolism. We want to make energy, we want to make ATP. So that's our ultimate goal. I'm showing you a diagram here where there's two atoms. Atom A, or it can also be a molecule, but in this case I'll say it's atom, and atom B. This atom A has these electrons that they're going to donate to atom B. And so when it does that, there's going to be two reactions. One's going to be an oxidation step, and the other one's going to be a reduction step. So I said two reactions. It could also be called as two steps. So let's define these steps. Let's first do oxidation. Okay, oxidation step. This is the step where the electron is lost by an atom or a molecule. So, step. I have a hard time with that E. Let's see, step where electrons are lost by a molecule let's see if I can undo that last step to write it a little bit better. Okay, by a molecule or an atom. So you're going to associate the word oxidation with the word lost. So I'm showing you here on the diagram on the left that electron A, when the arrow goes from left to right, that A atom is going to lose its electrons. So A is going to be oxidized. By oxidizing A, we're going to reduce B. So reduction. Simply the opposite. So it's a step where electrons are gained. Again, gained by either an atom or molecule. I'm not going to write it because I'm running out of room, but it's a step where this atom or molecule is going to gain electrons. So if you go back to this figure on the left here, where we start out with the atom B, it gained the electrons from A. So A donated them to B. So we're going to say here that B was reduced. So these redox reactions are going to play a very, very important role. You're going to see that they're going to occur different times or many times when we discuss metabolism. So this lecture should precede a lecture on glycolysis such that because during glycolysis we're going to see these oxidation reduction steps. Now just to step back before we go to glycolysis, a point worth mentioning is that in any biological systems, it's not simply the transfer of electrons, which I just gave you the definition, but it's also going to be a transfer of a proton, a hydrogen proton, as well as a hydrogen atom. So remember, hydrogen atoms are made out of one proton and one electron. So I'm showing you this right here. I'm going to circle one hydrogen atom. Here's a second hydrogen atom. This is going to be a molecule. We can call it molecule A. And it's going to donate these electrons to a molecule B. Now we've already talked about enzymes. So if you remember the lecture on enzymes, we talked about coenzymes. And NAD+ was a coenzyme, which we had mentioned is an electron carrier. Okay, so I just erased my scribbles to make it a little bit clearer. So we're going to focus on these hydrogen atoms. So in this case, this molecule A, I'll put this back in molecule B, which is NAD+. There's B. Doesn't want to write B. Let's try it again. There we go. Okay, so this molecule A has two hydrogen atoms. They're going to donate them during this chemical reaction, but not all of the atoms are going to go to B. So if you go right here, we're going to say because there's electrons involved, donated electrons, so A is going to be oxidized. So obviously if molecule A is oxidized, B has to be reduced, but look what happened to NAD+. NAD+ gained a hydrogen, so it went from NAD so you get the D plus here, the D. The pen doesn't always want to work. Let's see. There, NAD+. And it's formed, we've gained a hydrogen, so we're going to go from NAD plus to NADH. Okay, that H that we're adding to NAD plus means that we've added a hydrogen atom. Now remember, notice that the plus is at NAD+, but you don't have the plus in NADH. The reason being is that we have this little electron that came across, and he neutralized the plus. But what it gives off is this hydrogen proton. This hydrogen proton is going to stay in the cytoplasm. So this is what we're going to see in our biological pathways in our metabolism. Okay, this is all I want to say or mention about redox reactions. It's important that you realize this, and we're going to see this term again, and I'll mention it during the metabolic pathways.